Time to start at the foundation, and the foundation is physical. By the end of this session, we will be able to describe the SDA Physical Layer. Unfortunately, we can't build software-defined access on just any network. We need specific hardware in place in order to build an SDA environment. So in this video, we're going to explore what exactly that hardware looks like. We know that any software-defined access infrastructure has to start at the physical level. We need physical switches, which we've drawn out here. Now this is a little dark on purpose because really what we're going to do is build an overlay on top of this network. So for example, building tunnels between the switches where our users connect. Or hey, building tunnels between where our users connect and maybe up where the data center and the internet are. And so we're going to have all of these tunneled connections among all of these different switches. And this right here could be drawn almost like a cloud, because this is what Cisco calls the campus fabric. Fabric is another word for overlay, and really it's referring to the mesh of tunnels that we're building on top of our underlay network. So let's go ahead and reverse this drawing using the magic of video editing, which will allow us to study the physical layer. Now when it comes to the physical component, Cisco breaks this down into 4 different nodes or sets of responsibilities in the fabric. First of all, we have a fabric edge node. The fabric edge node is where we connect our users. It's the edge of the fabric. So look down here to where the users connect into the network, and these are all fabric edge nodes. So we'll label these with green. Next we have the control plane nodes. Now when we talk about the control plane in an SD access environment, we're talking about that protocol we mentioned called Lisp. And we're going to go into more detail on Lisp in future videos. However, for now what we need to know is that we are mapping out all of the different endpoints and their locations. So for example, we need to know if this user is connected to this switch. And believe it or not, we need to know that for every single user in the environment. So this is going to create a large mapping database on a particular node in the network. So the question is, which node in the network should we deploy this mapping database to? And in most cases, we want to deploy a dedicated pair of networking devices. Those could be routers, or it could be switches. We're going to connect them into the fabric and allow them to perform these mapping functions for us. The third role is going to be a fabric border node. The fabric border node is similar to the fabric edge in that it's going to sit out at the edge. However, it connects to other networks that we either know about or we don't know about. What do I mean by that? Well, for example, in our network, these 2 switches at the top, these would probably in a traditional network be our network core switches because they're connecting our campus fabric to all of the other parts of the network that exist out there. Well, in an SD access environment, these will be fabric border nodes, because they're connecting to other networks that aren't part of the fabric that we know about. For example, the data center, that's a known network, part of our infrastructure. It's just not part of the SDA fabric. Meanwhile, the internet consists of all of our unknown networks. So anything that isn't known, we think about our default gateway, right? It points out towards the internet because that's where all of the unknown addresses live. So we can break fabric border nodes down into internal fabric border nodes or external fabric border nodes, depending on what type of upstream network is connecting to us. Now in our drawing here, our fabric border nodes are connected to both the internet and the data center, and so they're operating in a hybrid role, which is also acceptable. Now one thing to note here is that we can combine the control plane node and the fabric border node together. So in our case here, we could get rid of these 2 extra routers that we deployed and have the fabric border nodes, our network core devices, serve both roles. It could be the fabric border node and it could be the control plane node. However, this isn't advisable in large networks and in networks where there's heavy roaming. So if our users are moving around a lot, that's going to tax the control plane node. And so at that point, we'd really want to have those dedicated control plane nodes back in our environment. Now the last role in this network would be a fabric wireless LAN controller, or WLC. The difference between a wireless LAN controller and a fabric wireless LAN controller is a wireless LAN controller that is aware of the SDA fabric. So in our case, we would deploy a wireless LAN controller and connect it to a border node, or it could actually connect in through an external network. So for example, if it's in the data center. And what this allows is for the wireless access point to still form a CAPWAP tunnel to that wireless LAN controller. This would be for all of the control plane information. However, a fabric access point would create a VXLAN tunnel to the upstream switch for data plane traffic, which means that wireless users would stay within the overlay, meaning it could connect directly to these switches in the fabric. So it's a different type of topology we deploy when it comes to fabric wireless LAN controllers and access points. Now you may have noticed a few nodes in here that we didn't color in. For example, these 4 nodes right here. In an SDA environment, these are referred to as intermediate nodes. Intermediate nodes do not have to have any special features. They don't even have to be Cisco switches. They simply need the ability to forward at layer 3. because again, their focus is connecting all of those tunnel endpoints to each other and not on any of the fabric services that are happening around them. Now last but not least, we do have to consider the controllers, because the controllers are part of the physical layer. And as we've mentioned, there are two controllers we need to concern ourselves with: the DNA Center Controller, or DNAC, and the Identity Services Engine, or ICE. Now DNAC, this is a physical appliance. It must be physically installed and directly connected to the SDA network. However, ICE has two forms. It can be a physical appliance, or it could be deployed virtually as a virtual machine. So we have some nice options around that. It makes it a little more flexible and easier to deploy ICE compared to a physical appliance in DNAC. However, regardless of how it's deployed, Cisco considers these two controllers to be part of the physical layer, at least as far as the installation and connectivity elements are concerned. And with that, you are able to describe the SDA physical layer. I hope this has been informative for you, and I'd like to thank you for viewing.